When converting between decimal and scientific notation, you need to use care to preserve the significant figures. In choice A, we see there's leading zeros. Leading zeros do not count as significant. This number also has trailing zeros in a number with a decimal point. When there's a decimal point in a number, trailing zeros are significant. So this number has 5 sig figs. So when we convert this to scientific notation, it must have 5 sig figs. To get the coefficient, we have to move the decimal point 1, 2, 3, 4 spaces. Our coefficient is 2.5600, and since we've moved the decimal point 5 spaces, our exponent is 5. Since this number is less than 1, it has to be a negative 5. And note in this number that there are 5 significant figures. In B, we have captive zeros that all count, so therefore there are 6 sig figs in this number. In order to get to a coefficient between 1 and 10, we have to move the decimal point 2 spaces. Our coefficient is 1.50002. We see that there are 5 sig figs, and our exponent is 10 to the positive 2 because we've moved the decimal point 2 spaces and the decimal number is greater than 1. In D, 3 sig figs, that captive zero counts as significant. Our decimal point is here. We have to move it 1, 2 spaces, so the number in scientific notation is 1.01 times 10 to the second power. Again, we see we've matched or preserved sig figs. In choice D, the number already is a number between 1 and 10. Our coefficient is therefore been determined for us, and we've moved the decimal point 0 spaces, so this is 4.2536 times 10 to the 0 power. Okay, a quick note, 10 raised to the 0 power, like anything else raised to the 0 power is going to be equal to 1. These next problems involve adding and subtracting numbers written in scientific notation. As always, make sure you write down the calculator answer first. So I've gone ahead and written down the calculator answer for each of these. The next thing to keep in mind is to convert each exponent to the larger or more positive value. Here we see 3 and 4. We want both of these numbers expressed to the 4th power. All right, when we look at this first number, to go from 10 to the 3rd to 10 to the 4th, we're going to have to multiply by 10. But we cannot change the overall numerical value of that number. If this half of the number is being multiplied by 10, we need to divide this half of the number by 10. I'm going to rewrite the resulting values lining up the decimal point. So we have 0.433 multiplied by 10 to the 4th power. Our other number is unchanged. Here's our intermediate result. By lining up the decimal points, we see that this number cannot go beyond 2 decimal places. For this number, 2 decimal places corresponds to 3 sig figs. So we look to our calculator answer. Know we can use 3 sig figs or 2 decimal places, and we can write our final correct answer as 1.52 times 10 to the 4th. And note we can only line up the decimal points this way when we have both of the numbers written to the same power of 10. Question 3 is a subtraction. both numbers already are expressed to the same exponent. We line up the decimal point so that we can look at decimal places. Okay, we look here, and we see the decimal place. We can only go to 2 decimal places, and this results in a number with just 1 sig fig. Our calculator answer is already expressed with 1 sig fig, so we can leave it here. This is one way to express the correct answer with the appropriate number of sig figs. And we can also write it in scientific notation as 2 times 10 to the minus 4. In question 4, multiplication division, all of the numbers contain only 1 sig fig. So our final answer should be expressed with only 1 sig fig. In this case, we must use scientific notation to express our answer with the appropriate number of sig figs. We must express this as 8 times 10 to the first. You might be tempted to express this as 80, but that indicates ambiguous sig figs. You can express it as 80 with a decimal point, as that would indicate 2 sig figs. And you certainly can't express it as 8, because that is not the same as 80. So none of these are appropriate. You have to use scientific notation in this case. Question 5, subtraction. So we first have to make sure that these are both expressed with the same exponent. We wanted to use the more positive, higher coefficient. So we're going to convert the second number to something times 10 to the 24th. To go from 10 to the 23rd to 10 to the 24th, we need to multiply by 10. We can't change the value of the overall number, so if part of the number is multiplied by 10, we need to divide the other part of the number by 10. I'll rewrite the result. Here's the result, lining up the decimal points, which we have to do in order to determine the sig figs. Here, we know we can't go beyond the second decimal place. We can only justify 2 decimal places, which in this number means that we have 3 sig figs. Go back to our calculator answer and express it with 3 sig figs. We're going to have to drop that 8. It's greater than 5, so we add 1 to the preceding decimal. And our final correct answer is 5.42 times 10 to the 24th.